Over the last couple of days, we've taken a look at scatter plots. And if we have a scatter plot on Google Sheets, it's nice because Google Sheets will plot for us a line of best fit, and it'll also give us the slope of the line. If we have a scatter plot given to us on a quiz or a test, however, we've got to be able to plot our own line of best fit. That's not that hard. Okay, a line of best fit is just a line that approximates the pattern that you see, which in this case would be a nice straight line, if you had a ruler, going through the middle like this. But we also have to be able to figure out what the slope of this line of best fit is. Now, because everybody's line of best fit is going to be a little bit different, what I'm suggesting to you that you do, in fact, what I'm telling you to do, is to use your calculator to determine the slope of this line of best fit. You don't have to actually do slope is equal to rise over run for this. Your slope might be different or will be different than the next person's. If, however, you enter all of these data points, all of the ordered pairs, the x and y coordinate of each of these points into your calculator, it will spit out for you, just as Google Sheets does, the exact slope and the exact y-intercept. There's 6 words, really, that we got to remember here. Okay, if you remember these 6 words, then you should be able to do this on your calculator. What are those 6 words? First 3 are? Stat, edit, 1. Right, stat, edit, 1. That's when you're going to enter your data. If I go to my calculator here, and turn it on, of course, and then I go stat, edit, 1, I see a table. In this case, I have my data already into a table, but if I didn't, then I would enter it in the table. Right? Now that I've got my data in there, stat, edit, 1, put your data in, then what do? What's my next 3 words? Stat, calc, 4. Stat, calc, 4. So now I'm going to go stat, go over here to calc, and then go down option 4, stat, calc, 4. Have to hit enter a couple times, maybe 3 or 4 times, depending upon which calculator you have. In this case, my slope is 9.44, and my y-intercept, b value, is 2.65. Does that make sense? You don't have to do it the old-fashioned way, okay? This is 2019, okay? Doing it the old-fashioned way, doing rise over run, that is so like 2012. Okay? This is 2019, where we're going to take advantage of the technology that we have at our disposal. It's not cheating. It's a function that's built right into our calculator. You have these calculators, we might as well use them, all right? Now, tomorrow, you're going to have a little quiz. It's going to be a simple little quiz. I'm going to tell you exactly what it's going to look like right now. There's going to be a graph that looks something like this, but there will also be a data table for you. I'll give you the table of values. Okay, that saves you the bother of finding the order pairs because they're already going to be there for you, okay? So what you're going to do is go stat, edit 1, enter your data, and then go stat, calc 4, and you're going to end up with this. This is what I'm going to expect you to write down tomorrow for 100%. If you write down y is equal to ax plus b, a is equal to 9.43566, and b is equal to 2.6536, or 2.6537, I guess it would be. Not these numbers, right? Okay, the numbers have to be tailored to whatever data that you have tomorrow. But if you write down this, just this, it's 100%. That's it. The reason that I'm asking you to write down all 3 of these things is because essentially that's my little test. Did you do it right? If you write down one number, right, it's easy to just like, oh, I saw it from my neighbor. Not necessarily on purpose, but you know, a 1-digit or 2-digit answer, easy to just accidentally see off your neighbor's paper, right? If you write down all of these to like 5 or 6 decimal places, then that means you knew what you were doing by entering it into your calculator. Stat, edit 1, put your data in, stat, calc 4, and then just write down what you see on your screen. 100%. Got it? Question?
How many decimals do you go to?
You know what? I'll tell you. I haven't actually made the quiz yet, but when I do it on the quiz, when I write the quiz and give it to you tomorrow, I'll say like, you know, do it to 5 decimal places or whatever the case may be. So I'm not actually sure, but I'll give it some thought. But should be easy for us, right? If you're having any trouble with that at all, come and see me and schedule help. I'll help you with it. We'll go through it again. Although I think just by what you guys were saying to me a minute ago when I asked you, what are the 3 words? Stat edit 1. What are the next 3 words? Stat calc 4. I think you guys are going to be fine with this. I think this might be our first 100% class average quiz of the year. Hopefully. Hopefully it is. All right, you guys good with that? Okay, here's what's not on tomorrow's quiz. Here we have a curved line on a position time graph. In a curved line on a position time graph, you remember from back the first day we introduced these graphs, meant acceleration. The object is speeding up. The line keeps getting steeper and steeper and steeper, which means it's getting faster and faster and faster. We need to find, sometimes need to find the instantaneous velocity. If we already have a straight line, the instantaneous velocity is easy. We did that on our quiz. Right? If the velocity of the line was 3 meters per second, then the velocity at any point along the line is 3 meters per second. But if we have a curved line and we want to find the instantaneous velocity at, let's say, 6 seconds, it's harder. What we can't do is just say v is equal to d over t. You could say, look, this d is what, 200, 240, 280, 320. Divided by the time here is 6 seconds. That would be wrong. That would give you the wrong answer. Velocity is not position over time. It's not 320 over 6. Velocity, rather, is displacement divided by time. And to get displacement divided by time, we need 2 positions. In order to get 2 positions here, we need a straight line. A straight line is what we call starts with a T, a tangent line. It's like skipping the rock off the water, almost. What's different about it? No, it does touch, actually. When you skip the rock off the water, the rock hits one spot on the water and then kind of bounces off. That's exactly what we want here, except that the rock actually changes direction a little bit when it hits the water, kind of bounces off and changes direction. We want our tangent line to bounce off of that one green spot right there, but we want it to be a straight line. So here's our rock. It bounces off of the water at that spot, but keeps going in a straight line. You'll know when you have a good tangent line drawn, because you'll be able to see that, look, there's a little bit of space before, a little bit of space after. It looks pretty uniform, right? Pretty symmetrical on both sides. If you find that it looks more like this, then that's not a good line. Right? That's not very symmetrical. You can see some space right here on one side, but look on the other side. That rock's not skipping off of that one point on the water. It's kind of hitting the water and then kind of going through the water, right? That make sense? So you should know if you have a good trend, or not, I'm going to say trend line again, a good tangent line, because it should be pretty much symmetrical on both sides. Okay, once we have that good tangent line, let me get it back to the good one here. Yeah, I think that was everything here. Once we have our good tangent line, then we got to pick 2 points, right? Pick 2 points on the line. Now, what I want you to make sure that you do is pick 2 points that are far apart on the line. Like, don't pick, you might look at this one and look at this one and say, oh, those are perfect points. Let's just go with those. Don't do that. Pick 2 points far apart. Like, ideally, either at the beginning or near the beginning, and at the end, or near the end. Here's why. Let's say, for instance, that you pick 2 points that are far apart. And the difference, let's say, I'm making these numbers up right now, but because you pick 2 points that are far apart, the difference in the position or the displacement is 100. You were off by 0.1 in your measurement. If a number is 100 and it was supposed to be 99.9 or 100.1, so what? Right? It's close enough, right? But if you pick 2 points that were close together, and the difference was only 1, and you were off by 0.1 now, that's a much bigger deal, isn't it? You were off by 0.1%. Now you're going to be off by 10%, which is a much bigger deal. So the idea is pick 2 points that are far apart, and then if your measurement does happen to be off by a little bit, it's not really a big deal. If they're close together and your measurement is off by a bit, it's a much bigger deal. Okay, so what do we do on this one? We would say, well, my final position, kind of hard to see it from where I am, but looks to be, what, 440, 480, 520, looks to be about 530-ish. But again, if I'm off by a little bit, I'm okay because I picked 2 points that are far apart. Minus 0 because my initial position is 0. Over, what is that, 8 seconds for my final time, minus, what is this, 2.4, 2.8, it looks like 3.2. 530, in this case, divided by, what is that, 4.8, gives me whatever meters per second. All right, here's what I'd like you to do right now, guys. Take a look at your worksheet. I want to say it was worksheet number 3. Yes, worksheet number 3. And I want you to take a look at the last question on the worksheet, question number 12, and do it at your desks right now. I've already got a tangent line drawn at 6 seconds. Should look something like this, nice and uniform on both sides, right? I want you to draw your tangent line, and then I want you to do what you do with it. Okay, let's solve this now. Remember, we want to pick 2 points that are far apart. I don't want to pick this point and this point because they might happen to be convenient, maybe conveniently falling on the intersection of 2 grid lines. It doesn't matter. Okay, I want to pick 2 points that are far apart. Again, the reason is if I make a mistake by even just the tiniest little bit, it's going to be a big deal if I pick these 2 points. If I pick 2 points that are far apart, it's going to be a lot less of an influence. So let's pick this one, and let's go right here. Okay, those are 2 points that are pretty far apart. Now we're going to say the velocity here is displacement divided by the time, or what else could we say instead of v equals delta d over delta t? The slope is the same thing, right? If you go delta y over delta x, a rise over run, that's exactly the same thing as saying delta d over delta t. So however you want to think of it works here. My displacement, or my delta y, is final minus initial. It looks like, what is this? This would be 500. These are going up by 50s, right? 550, 600, 650, 700. This looks like 550 minus 0 for my initial position, over my time is 12 seconds minus, what's this time? We're going up by 0.4s, I think. 0.4, 0.8, 3.2. It looks like maybe about 3.3. So we're going to say this is 550 divided by, what is that, 8.7? 550 divided by 8.7 gives me 63.2. How many people got an answer that's close to 63? Okay. Yeah, I'd take probably anywhere between usually about 10%, so probably about 57 to 69, somewhere in that range. Yeah, what'd you get?
I got 64.
Okay, that works. That falls in between 57 and 69, right? What'd you get? 56. Okay. That means if I was to take a look at your line of best fit, that's probably the issue. It's probably not drawing quite steep enough. If you take a look at it, my guess is that you have more space right here than you do right here. That would be my guess.